Welcome back to Peer Revue. I'm James, recording on Ngunnawal and Ngambri land. And this week, we'll find out why you can't have two vaccines if one of them is the COVID vaccine within 7 days of each other, but you can have two vaccines on the same day. But first, a question from a listener. Jared asks, why isn't my favorite map in Halo in my bookmarks? Thank you for your thoughtful question, Jared. The answer is, I don't know. F off. I did ask for questions, so I guess I got what I deserved. Okay, there's another question here. He also asks, where did the Big Bang come from? Okay, so the Big Bang is the start of the universe, yeah? And the universe is everything, yeah? So there's nothing outside of the universe that the universe could move into. The universe is space. Like three-dimensional space and also time. If all of this is true, then the Big Bang happened everywhere because the Big Bang was the whole universe. It was everything. And then it expanded. We have evidence for the everywhere part and the expanding part. So let me start with the everywhere part. In the 60s, this company called Telstar was putting solar-powered satellites into space to send phone calls and faxes and telecommunication stuff. Arno Penzias and Robert Wilson measured radio interference that was the same in every direction. This is the cosmic microwave background. It's energy in space. So the theory goes that in the beginning of the universe, everything was very, very hot. And as everything expanded, it got cooler. And space is quite cold, but not absolutely cold. At 0 Kelvin, no more heat can be removed. Near this temperature, you start to get phenomenons like superfluids and superconductivity. Anyway, the universe is like 3 degrees Celsius hotter than absolute zero. The Cosmic Background Explorer, launched in 1989, found out that the cosmic microwave background isn't exactly the same in every direction, but it has slight variation. My understanding is that if there was no variation, then everything would be an equal distance from everything else. So there would be no structure, no stars, no galaxy in the universe. The little variations allowed like two hydrogen atoms to come together. They had more gravitational pull, so they could attract more hydrogen atoms. And then that snowballed until the weight of all those hydrogen atoms crushing down on one another starts nuclear fusion and hydrogen turns into helium. And you let that happen for a few billion years, and then you get heavier atoms like carbon. Anyway, the point was that there's this electromagnetic radiation that's 13.7 billion years old that's pretty much the same in every direction, which provides evidence that the universe started at every point, everywhere, at the same time. Because we observe the same electromagnetic radiation everywhere. I'll put it another way. So, you know how they say that light from the sun takes 8 minutes to reach us? Well, the sun's really close, right? So we're only looking back in time 8 minutes because we're seeing what the sun, well, don't look at the sun, but the sun 8 minutes ago, well, the sun that you feel, the heat is 8 minutes old. But if you look at Alpha Centauri, which is 4 and a bit light years away, we're looking back in time 4 and a bit years. So if you look further away, we're looking further back in time. But if we look up in the night sky, nothing is uniform. You can clearly see the Milky Way where everything's bright, and then around it, there's just empty-looking spaces that are dark. But the Big Bang Theory predicts that if everything started from a single point and it was really hot, then it should have been really bright at some point, and that's exactly what we actually see when you look far enough away. Light is just electromagnetic radiation, like microwaves and X-rays and radio waves. It's not visible light. The wavelength is longer now because the universe is expanding, which we also have evidence for. That's the second part. So the universe is expanding for sure because the wavelength of everything in every direction is redshifted, pretty much everything, which means that the wavelength of that electromagnetic radiation is longer than it ought to be because it's moving away from us. Redshifting refers to electromagnetic radiation, but it makes more intuitive sense with sound waves. You know, so it goes kind of like this. When a souped up MX-5 doing a mani goes screaming past you at a constant 70 clicks an hour, it sounds like But if you're in the car, it's just like brrr. The pitch change is like the red and blue shifting. Blue shifting is when the light is moving towards you. So the light waves get squished together and appear more blue. So on the approach, the MX-5 has a higher pitched engine than it actually has. And when it's moving away, it has a lower pitch. So it's like... The same thing happens with stars, but they're not static. They're all moving away from us and from each other. So the universe is expanding and not from a central point. This is why the Big Bang Theory is the best theory we currently have for the origin of the universe, because it explains why pretty much everything is moving away from everything else and why when you look super far away, you see the same microwave radiation. And that's because the universe expands and it was super hot and super dense a super long time ago. I got my yearly flu shot last week and then my 4th COVID shot like 5 minutes later. And the chemist said that's fine. But it's not recommended to have the COVID jab like 2 days apart from another vaccination. But 8 days apart is fine. And I was like, what? And then I was like, whoa, this would be a really great piece of information for my radio show. So I looked up why. And the answer is, it increases the risk of mild to moderate reactions like fever if you have the COVID vaccination like 2 days apart from another vaccination, according to a Aussie government website. Just FYI, the Australian government recommends booster shots every 12 months for anyone over 65, and anyone over 75, it's recommended that you get a booster shot every 6 months. The space stuff, super good sources were NASA and Khan Academy, classics. Anyway, I'll be taking a break for the next few weeks until the next semester. I'll miss you, but I hope we can catch up soon.